All right, High Performance Django. How many people have heard of the book High Performance Django? Have read the book High Performance Django? Okay, a few, awesome. It's not actually 10 years old, it's 11 years old. 10 sounded like a nice round number, but we released it in 2014. Real quick about me, I'm the founder at Lincoln Loop. We are a web agency focused on Python and Django. We do really big greenfield project builds. We do performance and scaling, and we're full stack, everything from design and strategy to operations and DevOps, which is kind of my focus. Also creator of AppPack. AppPack is like a Heroku-like interface for your own AWS account because AWS is super confusing. And what we're here to talk about today, the co-author of High Performance Django. So High Performance Django came out of a lot of lessons that we learned building high traffic Django websites long ago. One of the first sites we built was a really large video game review site. So they would review video games. It had like comments and a bunch of social features. And when a new game would get released, they would get smacked with a ton of traffic. And also some really high scale publishing platforms that you've heard of that sit on the front page of Reddit or Hacker News all day long. So we learned a lot of stuff the hard way. Definitely took our lumps and dealt with outages and things on fire, and came up with a system that worked really well for us. And my light bulb moment for writing the book was an engagement we had with a client who had, 20 or 30 really smart Django developers on staff, and they were having this performance problem that they just could not figure out. And when we kind of lifted up the hood and looked at what they were dealing with, it was a mess. They had just completely given up on Django being able to serve any traffic at all. It was too slow in their eyes. So they had built this kind of background caching system that Django would never serve traffic, and when they made a publishing change, all the pages would get re-rendered and served statically, and it did not work well at all. So I sat down and kind of wrote my findings down, and was like, I could write a lot on this topic, and I probably wrote 2,000 or 3,000 words and said, hey, there's a book here, I think. At the time, Kickstarter was a really big deal, so. Before writing the full book, I went ahead and launched the book on Kickstarter. We set a target of $5,000, and I said, if we can raise $5,000, we'll go ahead and write the book. So that was May 12th, 2014. We hit our target in 3 days, $5,000, and we completed June 11th with just over $13,000 raised. That was followed by total existential dread that, like, I actually have to write this thing now. It was, the first few thousand words came out really easy. There were a lot of sections that were not super easy, either because, I wasn't as deep on the topic as I should have been. I felt like to be writing a book, or it was just not something that interests me, but it needed to be part of the book. So it was a painful grind. Towards the end, lots of imposter syndrome. What am I doing? I'm not an expert here, and lots more dread. But finally got it done September 12th, 2014. Thank you. Yeah. So this is the first question a lot of people ask: was it worth it? And I think a lot of people don't really share the numbers behind all this, and to figure out, like, is it worth writing a book of your own? So I'm happy to share. I already told you we made a little over $13,000 on Kickstarter. This is Amazon. We self-published the book, so Amazon does print on demand and Kindle, so a little over $10,000 there. And this is Gumroad. So Gumroad was PDFs and like e-reader format that's not Kindle. So a little over $33,000 there. And you can see all of these, there was a big push for it and then kind of a long tail. Quite honestly, I was exhausted and didn't have much to kind of keep this going over the years. So you can see sales have really trailed off. It's now for free online if you want to read it. But the total sales, $57,514.20. So was it worth it? I would say yes. We also, we run a consulting agency, and certainly it helps to be able to say, we wrote the book on this. So there's benefits there. There's also benefits. It's been really nice, like having random people come up to me and tell us that they've read the book. This is somebody I kind of randomly connected with on LinkedIn earlier this year, and they said High Performance Django was essentially required reading at their work, and they had 1 million subscribers and thousands of concurrent users. So stuff like that feels good. It's had some legs, and I think we've really helped some people. So I would say I haven't looked closely at the book in many years. The talk got accepted, and I picked it up and I reread it. I had a lot of feelings and emotions rereading it. My first one was kind of like this is still pretty relevant. Like this will work, and kind of followed by like giving myself permission to be like, this is good. I think when we do stuff on our own, we see all the problems and the warts and the things that could have been better. But I felt like, I'm proud of this work. And there were also a lot of these of just like, what was I thinking? I would not do things that way anymore. A lot of realizations that technology in some places has moved quite a bit from where we were in 2014. So with that in mind, I'm going to go through some sections of the book and talk about places where I think we got it right, places where I think we got it wrong, places where the world has moved to a different location, and I would do things differently. So this is definitely a subset. I had a hard time getting this talk into 45 minutes, and last night butchered a bunch of slides out to try to get it in there. So start off with the first chapter is called The Big Picture. And the big picture is basically just painting what we're going to be doing, the general architecture we're going to be using, the systems we're going to be using. We start off with talking about simplicity, and simple sites are easier to scale, easier to understand, and easier to develop. I am 100%, 100% still believe this. It's the way to go. As you build software, over time, it just has a tendency to collect complexity, and you really have to push back and fight it. For us, simplicity is as few moving parts as possible, and you can define moving parts multiple ways. It might be services you need to run to, service the application. It might be the lines of code you have. It might be the dependencies you pull in. The fewer, the better. Using proven and dependable technologies, I really loved Carson's keynote on the first day. He referred to these as seasoned technologies. Instead of whatever the new hotness is. The interesting thing about kind of what we talk about in the book is it's really not new information. People have been scaling Perl sites and PHP sites and Ruby on Rails sites using a lot of the same techniques over the years. And so there's prior art here that we can lean on. Using that kind of is the next point, proven and dependable architecture. This has been done before. People know how to do this. And deflecting traffic away from complex parts. The most complex part of your system is probably your own code. So anything you can serve out of cache or work you can do elsewhere is going to be beneficial in the end. Love it. Totally on board. And some of you may be hearing this and saying, that sounds a lot like boring technology, which we talk a lot about. I looked up, this was an essay by Dan McKinley It was actually published 8 months after our book, so I'm not saying he took inspiration from us, but he definitely didn't. He learned all these lessons working at Etsy, and I think there was some kind of appetite in the tech world around this time of like, what are we doing? We're making our lives harder, and let's get back to doing things simply and boring. And one interesting thing is Django has kind of swung from one side of the spectrum to the other in that time. At the time, in 2014, Django was still kind of new, kind of interesting. People didn't quite know, how to work with it in this scale. And now it's kind of firmly, I would say, in the boring technology in a good way. It's, you know how it's going to behave, you know what it's going to do. This is a picture from the book of roughly kind of how a request goes through your system. It's going to go through a load balancer. We call the next layer the web accelerator, which is kind of a term that people don't really use anymore. I don't know if they used it much then. It's essentially Varnish or a CDN, your application cache database. One thing I would change here is I would move this layer up. So we used to deploy our application, and we would deploy Varnish instances behind our load balancer, and Varnish is a tool that lets you serve traffic really, really fast. Today, I would push people towards using a CDN for this, and we'll get into that here. So these are the some of the kind of tools we recommended in this space. I tried to be somewhat opinionated in the book. Now I'm probably even more opinionated. So I would say these are the tools I'm looking at today. Amazon load balancer, most of our stuff is deployed on Amazon. If you're using Google or Azure or whatever, they all have a load balancer that you can use. Cloudflare is my kind of CDN web accelerator of choice. Fastly is also awesome. They handle PyPI's traffic, and they're essentially like a very fancy hosted Varnish. We still use uWSGI. It has kind of, the maintenance of that project has sort of ebbed and flowed over the years, so I'm a little like hesitant to jump on that one. So I would say gUnicorn's got the mind share and it works. For a cache, I would just choose Redis or Valkey, the open source fork, and we should all just be using Postgres. There's not really a great compelling reason to use MySQL anymore. So next chapter is the build. We get into like specific tools, how we make this all happen. One of the big themes in this talk is the book was very server related. You're getting a bare Linux server and you're installing your tools on it. And Docker was a thing in 2014, but it still had some rough edges. I don't think the hosting platforms were there as much. Now I think it's the place you want to be. One of the big motivations for this for me, maybe big's overstating it, but I think a lot of folks are dealing with compliance and security issues these days, SOC 2 audits and things like that. Not managing your own servers is a huge thing that you don't have to deal with, and that like if you manage your own servers, they're going to ask you how you manage your SSH users and what sort of encryption you're using, and what antivirus you're running on your Linux servers, which is nuts. What you're using for intrusion detection and all this stuff. And going to managed containers, you can just be like, look at Amazon's SOC 2. They'll answer all that stuff for you. So if you're in a kind of secure environment, I'd say there's even more compelling reasons to do this. And again, this is my opinion. People certainly still deploy on servers. I had a great talk with one of the devs that works with Adrian on SoundSlice about how they're deploying, and it's like deployments from 2005, and it works awesome for them, and I loved it. Like, I was kind of envious of the simplicity of it. So you can do it any way you like, but this is my recommendation. So I'm going to go through some quotes from the book. One strength of Django is the Python ecosystem, 100%. Unfortunately, a lot of the things you'll find out there, reusable Django apps, are not built for high-scale, high-traffic situations. So you have to be really careful about the packages you pull in. And you need to understand kind of how they're working, what they're going to do on your database. And you may find, a lot of these were built for very flexible, to be very flexible and fit lots of different solutions. And you might find that a very focused solution might be a better option for you. So just be cautious, don't pull in the world. Another caveat here is if you want to build software that lasts 5-10 years, you have to be really careful about the things you're pulling in randomly from the internet, because a lot of them die and don't get maintenance, and you have to be ready to say, all right, now I have to take ownership of this because we use it and we depend on it, but it doesn't get updated anymore. So proceed with caution there. We have a whole section on optimization. So in almost every web application, the database is the bottleneck. This is still what we see. There are some exceptions, but generally your database is going to be the slow part. So dealing with that, we get a lot of folks that come to us with performance problems, so we get to see lots of different apps and the problems they have, and I'm going to highlight a few of the ones that we had in the book that I also still see with everybody that comes to us. If you don't keep track of what your application is doing, if you don't have a way to monitor it and like an application performance monitoring system, and nobody's looking at it, it's very common to see pages that have hundreds of database queries on them, sometimes over 1,000. So select related and prefetch related are your friends here. They're super easy to use, but you just have to identify when to use them. The ORM makes it really easy to trigger these N+1 queries where you're looping over a set of blog posts and looking up an author's name, and that's triggering a query on every loop. There's a package out there called Django Zeal, which is interesting for using in development. It can catch some of these before they make it out into production. Thumbs up on that one. Missing indexes are interesting. So missing indexes in your database, when you build your application and you have a few thousand rows in your database, you never notice that you're missing important indexes. And then your application gets popular and you go from a few thousand rows to a few million rows, and you really start to feel this pain. And if your developers are all working on databases on their local machine that are like, kind of little developer databases, they're never going to notice this. So finding these places and applying the right indexes is another place where a APM, application performance monitor, can help a lot. And it kind of requires some specific database knowledge to understand where to put these and how to test that they're working and all that. But we go into that in the book. I will say LLMs are really good at this stuff. So doing an explain analyze on a query and putting your table definition into the LLM and saying, like, how do I make this faster, can often yield good results. Counts, again, 100% on this. Using like .count on a query set, once you get to millions of rows, it's not an option. Like, it will 100% be slow, and you can't make it faster, really. You need to look at avoiding those wherever possible. You can do approximate counts, and there's solutions around this, but if you're using counts a bunch in your code, that's going to be a problem. This was a topic that we were really hot on at the time, query caching, and I don't hear too much about it these days, but it's the idea, you have a middleware in your application, and essentially any calls to the ORM get cached. So every database query you make ends up in a cache, and if you make that database query again, it comes out of cache. If you write to the database, it's smart enough to know how to invalidate parts of the cache. For this, I'm kind of like, I wouldn't say many workloads. I'd say some workloads. If you're really read heavy, this is still something worth looking at. Johnny Cache was the package previously. Django Cache-a-lot is now the one that I would look at. But these come with some big caveats, so yeah, I don't know. Be careful there. Doing slow work later. I am 100% on doing slow work later. I feel like just telling people use celery is maybe negligent. Like celery is a frickin' beast of a thing, and it has 8 million knobs you can twist on it. And what I see is it does not behave the way people expect it to when they pick it up and start using it, and you hit all sorts of strange edge cases. So I still think celery is probably the job queue of choice in our world, but I would probably spend a lot more time explaining some of those knobs and how they affect the way the queue acts. The other thing that I think has come up in the meantime is async. Python async is really interesting, and celery is not really like an async native queue, and we are building lots of apps now that are making calls to LLMs that are HTTP calls that take 2 or 3 seconds. And if you're not using some sort of concurrency model there, having a CPU sit and wait 2 or 3 seconds for a response from an LLM is not an efficient way to operate. So one of the projects I'm interested in, and I haven't had a chance to work with much here, is called Temporal. There's also some other open source stuff in the Python world that is a little more async native. In 2014, hosted CI was not so much of a thing. We had Travis CI, which was a big deal, and everybody used it for their open source apps, but I don't feel like people were really using it for their like internal projects. I would not use Jenkins anymore. We use GitHub Actions. Whatever comes with your code repository service is probably good. Your cloud provider probably has something too. This is a theme we'll get into in a little bit, but let somebody else do it. So next section is deployment. For deployment, we have a section on auto-scaling, and it's kind of like a lukewarm, like, yes, auto-scaling exists, but it doesn't work in a lot of scenarios. Auto-scaling's gotten a lot better. There are databases now that do auto-scaling, Postgres databases that do auto-scaling, which is a really interesting thing. It used to be moving your database to a larger size or doing that dynamically was like, impossible. So that's interesting, and I think as you move from kind of server-based thinking to container-based thinking, auto-scaling gets a lot easier. So I'm a fan of auto-scaling. I would probably be like a little more hot on it now. I don't use it for all databases, but in some cases it's a really compelling option. The one thing I would call out on auto-scaling is auto-scaling is great if your traffic goes up like this, or like this, I don't know. But it's not great if your traffic does this. You need a minute or two for the autoscaler to see like load is rising or whatever metric you're catching it, and then it needs some time to pull down containers and spin them up and pass a health check. So scenarios where we see this are overzealous marketing teams sending out an email blast to like 250,000 people, and then like half of them click on a link right away. That's a good way to take your site down. Ask them, either plan for that or ask them to spread it out over some time. Also, we see this in like classroom environments. So you build like an education simulation, and a lecture hall of 300 people is all going to log into the application at the same time. Logging in is actually like a really expensive thing on CPUs intentionally because password hashing and all that. So those auto-scaling won't help you. I mentioned this theme. I think in 2014, I felt it was much more important to me to run all the infrastructure ourselves and to be self-hosted. And I think the gray hair and having 10, 11 more years of experience, I am much more in the camp of just let somebody else do it. It is expensive. The people look at a cost of $1,000 a month and they're like, this is crazy. I could put this on a $5 VPS, and you're counting your time for $0 when you make that assessment. The total cost of ownership of solutions is much higher than just starting a container up on a system. I actually read an interesting article about this. There was Datadog came out with their financial report years and years ago, and it was obvious that they had lost a single customer that was paying them $65 million a year. And the customer was Coinbase. And so it's the pragmatic engineer. He went around and he's got contacts in all the big, organizations and said, this seems nuts. At what point do you actually start considering moving a vendor relationship in-house? Like what costs are you looking at? And the general consensus he got there was $2 to $5 million a year. So, think about the team it takes to maintain these things. Think about the expense of when you're working on your application versus working on some ancillary service that somebody else can probably do a lot better than you. It might not be $2 to $5 million for everybody, but it's probably the $500, $1,000 bill. You're probably going to make up by being able to focus that time on your application versus other stuff. So first up in this category, Postgres. We're talking about Postgres. You install Postgres on a machine. There are a whole bunch of dials you got to turn to make sure that Postgres actually can use all the resources on that machine. Just use RDS, use crunchy data, use a managed provider. Not having to worry about backups, not having to worry about having simple paths for upgrades, being able to quickly switch machine sizes, not having to worry about replication. This is one that I was glad to hand off, and I hope to never have to administer a database again. The observability stack. So this is one, at the time we were using Graphite. That was kind of what people used. Graphite's no longer really a thing. Prometheus is the new thing. Again, I would recommend you don't bother running that yourself. Let somebody else do it. And there's, beyond the kind of total cost of ownership and time, there's some compelling reasons not to have your monitoring and alerting running on the same infrastructure as your application. If if something goes down, you really want your alerting system to let you know. And if it's all in the same place, that might not happen. Alerting, this one, I'm kind of just like, what the hell are we doing here? I feel like there weren't really great options in this space in 2014. There were some systems that were designed for, I have a rack of servers in my colo, but like the modern stuff wasn't really all that mature. Again, I feel like there's other providers that do this. Datadog's great. Amazon CloudWatch it works. Your other cloud providers will offer something here as well. Logging, we were on kind of this like modified Elk stack. This was one where I was like, we're like talking all about like simplicity before, and like now I'm asking you to run Elasticsearch and all this stuff. Like, no, like don't do it. Let somebody else manage this for you. Again, CloudWatch, Datadog can do it. Sentry just released a logging product, which is exciting. They're great folks. Error reporting, I actually feel better about this one. We did okay. I still think Sentry is like a key piece of infrastructure for any application. It doesn't have to be Sentry, but they're Django, they're great. Like I just say use Sentry. Their open source is like, they're a little less open source now, but it shouldn't matter, use their hosted version. Okay, so preparation is the next part. Preparation is, you've got your code ready, you've got your infrastructure and your deployment all ready. How do you make sure that you're not gonna just completely topple over once you start sending traffic to this? So this section is largely about JMeter. We had somebody working with us at the time, Brandon Conkle, who did this like awesome blog post series on JMeter. JMeter was kind of like the king in load testing at this time. His blog series is great for JMeter. I don't really think JMeter is where I would go anymore. Hey is a really cool tool. It's written in Go. It's super fast. It's great for testing like individual endpoints. If I wanted to do something more sophisticated, like I want a user to log into the system and post an image and then browse to their profile page, I'd be looking at something like K6 or Locust. But the reality is I put a lot less focus on load testing these days because infrastructure has gotten so good at being elastic and it's so easy to kind of adjust sizes on things on the fly. I'm looking at load testing to just give me a sanity check that I'm in the right ballpark, but I'm not going to have a massive load testing suite that tests every single option. You're going to be wrong with whatever you do with load testing. You're going to think users are going to do something, and they're going to do something else that completely surprises you. So it's kind of like the 100% test coverage thing. Just because you have 100% test coverage doesn't mean you've actually your code is bug free. Okay, so there are some things that I didn't cover in the book, either because they just didn't exist at the time, or stuff that we've kind of learned and adopted since then. The first one is Django channels and async, which is really cool new tech from Django. Well, newer. I have not had an opportunity to run these in a really large scale environment where performance is a concern. So I reached out to some folks to get info from people that are doing it, and a few of the folks I reached out to that had been kind of communicating on tickets and seemed like they were using it in their bigger companies were like, we can't use it because we have seen various blockers, like somebody wanted to use memcached or I don't know, various reasons why people couldn't use this. The people that were using this, I got the impression that they have learned a lot of stuff the hard way. I think this is more, when we talk about Django being boring technology, I would say Django channels is probably not boring technology. You're going to find some interesting stuff heading this way. I don't think that's to say you shouldn't use it, but just be aware. One tip I did get is the Django channels Redis package is use the pub/sub channel, not the Redis channel layer. Everybody I talked to that was using it said the pub/sub layer is the one that scales much better for them. Another topic I would talk about is continuous deployment, and I think everybody probably that uses some sort of CI system is like, oh yeah, we do continuous deployment. CI/CD, I do continuous deployment, but I'm talking about real continuous deployment, where a feature's done, it's accepted, it goes live. Not we have a date that we are going to do a release, and we're going to wait for all these new features to pile up, and then we're going to toss them all out into production all at once. One of the things that's great about real continuous deployment is you get a lot of practice doing deployment, and deployments are probably the most likely place where something's going to break or go wrong. And the more you practice it, like any muscle, the better you get at it. And then also your change sets that are going into production get much, much smaller. And it's much easier to debug small change sets that cause problems rather than a month backlog of work that all goes out into production at the same time. So I would really stress this, just get good at deploying all the time and get comfortable with it. And if you're having trouble with deployments, and it's most folks are we had a deployment that went bad, we're gonna do less of that. And really you need to do the exact opposite, lean into it. Why did it go bad? How do you fix it? How do you kind of keep this ball rolling forward? Rollbacks are one of the ways you do this well. So one of the most stressful things about a deployment gone bad is you have to fix it on the fly. And trying to debug an issue and quick code up a fix and quick push it out into production is a good way to end up with like much bigger problems, to totally stress out your team, ruin morale, like have turnover, like nobody likes this. Rollbacks are a great way to be like, hey, this deployment, there's something going on, we don't know what it is. I'm gonna, click a few buttons and roll back to a previous version that we know is good, and then we can take the time to figure out what went wrong. For rollbacks to work, you need backwards compatibility. So wherever the state is managed in your application, usually it's in the database, you need to make sure that the state is compatible with both the previous version of your application that's running and the current version that you're deploying. So this means thinking about Django migrations a little bit differently. You can't just go in and say, hey, I'm just going to rename this column, or I'm just going to drop this column out of the database, because you can't roll back. You're burning the bridge behind you, and you're saying like, we're doing this no matter what. So there's lots of good talks and who gave Tim Bell gave a great talk about this. Was this in your talk, Effa? Yeah. There's talk this DjangoCon about it. But yeah, so backwards compatibility, it makes it possible to do rollbacks, which makes it possible to do real continuous deployment. So to wrap up, this is the quote we kind of end the book with, and I still think it's great. Instagram is famous for scaling to the size where they were millions and millions of users with a skeleton team of like 3 people that didn't really know how to do deployments or operations. And this is from a post of theirs from 2011. And so their principles were keep it simple, don't reinvent the wheel, go with proven and solid technologies. And they're Django as well, if you didn't know that. And the Threads app from Meta is also Django. So lots of examples of high-scale, high-performance Django still out there today. And that's all I have.
Thanks, Peter. Do we have questions?
Hi, Peter. Thank you so much for the presentation. I have a question. Do you have a plan to rewrite the book with these new changes?
Maybe. I'm just recovering from all that grief and trauma from before. So yeah, maybe.
That would be awesome. Yeah. Thank you.
So one of your big themes was just use Postgres. Also, you mentioned you have to be careful what you take from the internet because it might not be around in 5 to 10 years later. So if you're a commercial company with downstream users who also use your database, which is not Postgres, how do you recommend A, getting buy-in to switch to Postgres, and B, switching to Postgres when you have database exclusive users?
Well, first I would say if you're not feeling the pain, maybe it's not super high priority, but if you are feeling the pain, there are, I'm assuming we're talking about MySQL here. I think from a business perspective, there are, the licensing situation with MySQL has gotten cloudier over the years, and how updates are handled with MySQL has gotten cloudier, and I'm not super deep in that, but I've just kind of seen these rumors. I also think there are some features in Postgres that do not exist, so if you can kind of make a compelling argument that we really want to use this awesome feature of Postgres and it would help us do X, and we can't do that here, or if you can point to, we had this performance issue that affected users, and it's because we didn't have this functionality over here, or because we don't fully understand this database well. I think another thing is playing to your strengths. So if you're in a place where like everybody knows MySQL inside and out, maybe MySQL is a better choice for you. But if you're in a place where people are like, yeah, I don't know either way, maybe there's a compelling reason to switch. There are some tools that will let you switch, basically take like a MySQL dump and turn it into something you can import into Postgres. I don't know them off the top of my head, but we were just working with a client who did a conversion like this. So I'd be happy to get that info to you and or introduce you to them because they may have some thoughts on it. And they also had a reporting database that some of their clients could connect directly to the database, and they switched it all to Postgres, and it seems like it was successful. So yeah, I can get you more info. Has anybody here done that?
Was it
Switch from
I think
MySQL
this
to
on.
Postgres? Yeah. What did you use? Oh, you have a question?
Do you see fewer query-related issues from teams that use tools like Django Debug Toolbar for introspection during their development process?
That's a good question. No, I don't think they are. I think the worst ones are if somebody has eyes on it, it tends to like not happen, or at least somebody catches it early. The worst ones are when people are just blindly like, it's not on the radar. It's like this code is working on my machine and we're going into production, and then like we're getting reports of slow responses, and like nobody's plugged in any sort of performance monitoring ever or ever looked at it. That's where, yeah, like you really, that's kind of one of those places where like complexity just like creeps in. Like it's it's 10 milliseconds here, it's 20 milliseconds there, and like over 5 years you're at like 20-second response times. So yeah, keeping an eye on it's probably the biggest thing. I can repeat you.
Thanks for a great talk. Along those same lines, good news coming in a likely future version of Django. There's a feature, maybe you've had a look, model field fetch modes, where model by model or query set by query set, you can tell Django to fetch related entities by default.
Cool.
To not have to maintain manual lists of related entities, which can be brittle if there's drift.
Yeah.
But I'm going to turn that comment into a question. Are there other features like that that you, in your experience, you've seen if Django shipped this, it could help developers kind of stay with the grain of Django instead of developing the conception, which I've seen is like, oh, Django's slow.
Yeah, that's a great question. I hadn't thought about it, but I do think like I see like all that performance stuff, and I don't know if it's Django Debug Toolbar or something like this Django Zeal package, like being able to call out like you're making an n+1 query, because it's a super easy fix, and it's super easy to do too. So if we in debug mode, if you could just have a warning that's like, hey, you need a prefetch related here, that might be interesting. I think the performance monitoring stuff is probably out of scope, but I do feel like it's mandatory. One of the things I'd really love to see from Django is a more opinionated, like, here's how you deploy, here's how you go to production. And I think we kind of let users just figure it out on their own. And yeah, I think a lot of people flail with it, or they're pulling up some random blog post that may or may not have good information, and just giving people guardrails and like if you do this, you're going to be in good shape, I think would be really awesome. I don't think it means we can't let people pick weird tools and do stuff other way, but it would be awesome to just be like, this is what we recommend. Yeah, which isn't really a code thing. I think it's more of a documentation thing.
Thanks, Peter. In the interest of time, I have a final question here. How do you balance performance with cost?
Yes, that's a great question. So doing all this takes time. And at some point, getting a view to respond, a view that responds in 200 milliseconds to get it respond in 100 milliseconds is not not valuable to anybody, especially if it's like, it's kind of that 80-20 rule. Like a lot of times you can get a lot of work done in the performance work done in the 20%, and doing the last 80% may not be valuable. So I think coming up with some kind of definitions, I think, of like what are our targets? How much time do we want to invest in this? Is it okay that this one thing is slow? And kind of not losing sight of, most of us are coding for, or writing code for businesses that are trying to make a profit or trying to make users happy. And if you just kind of go down the rabbit hole of like, I'm gonna, tune everything and make it great, and like, is it making things better for users? Is it, a lot of times performance is often related to cost, in terms of, the slower your application is, the more CPUs you are going to need to serve your application. So there are some compelling reasons to, get things optimized. You can run on a smaller database, you can use fewer containers, but there's a point of kind of diminishing returns for sure.
Thank you, Peter. A round of applause for Peter.